Chapter 3, Assessing Cloud Needs. So if you want to, go ahead and hit pause and read the introduction starting on page 77. So when we're going into Chapter 3 and we're talking about cloud assessments, we're taking a little bit different view on things than we have for the previous two chapters. So in the first two chapters of the book, we talked about cloud concepts and characteristics, and the material definitely had a more technical slant. That's because we're talking about networking and data storage. So we really have to learn the details behind those. For the rest of the services, we're going to be able to think about these and speak to these from more of a business mind. Because, even when we're talking about compute, we're talking about the underlying infrastructure of the application. Well, as a business user, we should know what the application does. If we don't, there's another problem altogether, but that's a conversation for another time. But if you find yourself in a position where you're talking about cloud, you're introducing cloud to the corporate executives, or if you are charged with going out and implementing cloud, and you need to be able to speak to people and convince them that you are moving to the cloud. So various things that we need to do from business speak without the technical jargon. So again, we started out talking about networking and data storage. Those two we really had to be more technical. But then now, as we move forward, we're going to be talking about things from a business view. So for the remainder of the course and the remainder of the book, you're going to find the material a little less technical and more geared towards determining business needs. Now, that being said, the more you understand it technically, and I'll try to provide that information as well, it gives you a little bit more to go on as you're talking to your business and talking to potential users. So we'll approach the rest of the material with more of an open mind. And for the rest of this chapter, we're also not going to assume that we are moving to the cloud. We're going to talk about assessments and discuss all of the conversations and things that we need to have in order to pull the information from the business, from the executive team, from the company to determine if we're moving to the cloud. And then beyond, if we're moving to the cloud, then we're going to start talking about CSPs. Does it make more sense for us to go with Azure? Does it make more sense for us to go with AWS? Should we be looking at Google? Should we be looking at Oracle? Should we be looking at IBM? There are any number of cloud providers out there. And so those are the kinds of things that we're going to be discussing throughout this chapter. Okay, so when we're going through this, and of course, this slide right here is just a good cover of everything that we're going to talk about in this. We're going to be talking about cloud assessments. We're going to talk about gathering current and future requirements, key stakeholders, asking the right questions, running feasibility studies, conducting gap analysis, using reporting, understanding benchmarks, and then creating documentation and diagrams. And then the second half of the chapter, we're going to be talking about understanding cloud services. Now, this is where it really gets fun, especially if you haven't been exposed to all of the cloud services that are out there. We're going to be discussing them, and this is really going to open your mind to what this beautiful thing is out here called the cloud. Of course, the cloud, the strength of just getting rid of our data centers and moving into the cloud and replacing our need to create servers and using our compute options, using our storage options, doing the networking out there on the cloud instead of having to order equipment and hire people to do our networking inside. But then we're also going to talk about things that we can do, like our databases that we can bring in and not have to install on servers. We'll be talking about artificial intelligence, machine learning, digital marketing, Internet of Things, blockchain, subscription services, collaborations, virtual desktop images. So we're going to be discussing all of these topics, again, not from a technical perspective, but from a business perspective. Okay, so now read pages 79 through 89 if you want. It's kind of up to you. I don't know if you like to listen to this first and then read the book, or read the book and then come back. You find what works best for you. I personally think it's better to read the sections, listen to the lectures, and then go back and read the book in its entirety. And the reason I like to do this is because you get to add to your notes, you add to your highlights, and you'll recall things that we discussed there. So again, you find out what works best for you. If you're going to follow along with my suggestions, I would say to hit pause and read pages 79 through 89, and then come back and we will discuss cloud assessments. Okay, so using cloud assessments. So what are our main goals for assessing what we need, what our business needs are? Because we want to create good, solid requirements and artifacts so that whenever we implement things, we understand why we did, and it just helps the entire process. So part of what makes a good cloud assessment, we want to gather current and future requirements. We want to find out who the key stakeholders are. We want to make sure that we're asking the right questions. We want to be running feasibility studies, conducting gap analysis and using reporting, understanding benchmarks, and creating documentation and diagrams. So as your book points out, it's entirely possible that one of the reasons you're implementing the cloud is that some executive came in and said, we need the cloud, make it happen. That very well could be the case. I have been part of programs where that is the case. But nonetheless, you really need to follow the steps that we have laid out here, because you're going to need to convince the business, no matter where it came from and why you're moving to the cloud. You'll always need to be able to convince the business users and your information technology teams and everybody. You want to make sure that they're all part of the team and that they all have a good feeling and know why they are moving to the cloud. So regardless of what that motivation is, these steps should be followed. So when you look into the different CSPs, mainly Azure, AWS, Google, these very large cloud service providers, you can look at their frameworks. And their frameworks, while are specialized for their products, they really all kind of point to the same type of framework. So what we're looking at here are these 5 steps of gather requirements, assess them, and then design, and then implement, and then your final step is operations management. So we'll go through this, but where we're really focusing now is on our gathering requirements. We need our business requirements, our technical requirements. We also want to make sure that we get with the right stakeholders, and we'll discuss that in great detail here in a few slides. And then we're going to do our assessment, and that our assessment includes creating baselines, make sure that we store the baselines. We can come back and check our baselines, and we'll talk more in detail about that. Feasibility and gap analysis, and then we'll design. So this is how we define the future state, and then implementation. This is when we take that step and we move over and we migrate into the cloud. And then again, finally, we have our operations management. This is our ongoing assessment. No, I'm sorry, ongoing operations. So when we start our assessments, we want to make sure that we're asking good questions and that we're getting to the core of the information we need and to understand why we're moving to the cloud and what we're going to do once we get there. Now, again, we did talk about situations where maybe somebody says, you're going to the cloud, figure it out. That very well could be the case, but even if that is the case, you want to make sure that you do a good job of working with the organizations, making sure you have all the stakeholders in the room, make sure that all of their concerns are addressed, make sure all their needs are addressed. So we're going to start going through and talking about some questions that we can ask to generate those things. Now, another thing I like to point out here is I know that you're taking this course online. You're reading a book, but I'm hoping that you're doing it also with some peers, because these are the kind of things that you need to practice. And you need to be having conversations with peers. And the reason that you want to be having conversations with peers and friends is because you want to be able to stop and say, you know what, I might be beyond what I understand right now. And you want to be able to do some research. So I always kind of laugh at, I've been in IT for working on 30 years now. And I have been in restaurants at lunch where me and my friends would sit around and we would talk about some technical thing. And we would debate different items. And there are times when you look around and you realize, oh, we're the nerds in the room, and people are looking at us. One time in particular, I remember some friends and I. It was around the when there was a big oil spill, so that tells you how long ago this was. It was the Exxon Valdez, and we started talking about what we would implement to keep something like that from happening. And I don't remember. We were in just some restaurant. It wasn't even a nice restaurant. It was like a fast food restaurant. And we were sitting in there, me and about five of my coworkers, and we were talking about what we would do. And I don't think we realized how nerdy we were being and how loud we were being. But the manager came over and pretty much stopped us from talking and asked us if we were okay, if we needed anything, and then kind of just looked at the door. And that's when we realized that we might have gone a little too far. So anyway, I bring that up just as a funny moment, but also just in the spirit of understanding that you do need to be having conversations with people about these topics. That's the only way to keep it fresh. And it can sometimes feel annoying, kind of rehashing the same conversations, but really and truly, understanding what is cloud and the things that you need to know there, and being able to talk to it, being able to discuss architecture is the absolute best thing you can do for yourself to be able to do this in the future. So anyway, we're going to come in here and we're going to start talking about some of these questions. So with our using cloud assessments, one of the questions we might start out with is, does your business need the cloud? This is a biggie. There are certain cases where moving to the cloud is not cheaper, is not a better thing. Especially if you are running a very small shop and you know everybody knows exactly what they're doing. And if you have people that are maintaining your hardware that are also your software developers and they work inside the building with you, there's a there are opportunities to do things cheaper than you could ever actually do in the cloud. Now, I will say, as I've been working in the cloud for almost a decade now, I think that for the most part, I can get around those cost issues and I can show people that it would be cheaper to move into the cloud. But that being said, we're still starting out with our first question. Does your business need the cloud? And one of the reasons that there's lots of things that we want to look at to make that determination. Some follow-up questions we might have is part of your business already in the cloud? A lot of businesses, when they first start moving things to the cloud, the first and easiest thing to take advantage of is object level storage. We talked about that last chapter. It's kind of hard not to find a good use case for that. Because if you think about storage, when you go buy a disk, you can't buy part of a disk. You have to buy the entire disk. So sinking money into disks that are only available in one place, and unless you build some process to back it up and to have it in multiple locations, like availability zones, then it's really hard to beat cloud, especially the cloud providers. And they offer tools, especially like Amazon Simple Storage Service is one of the best and easiest ways to get people to dip their toe into cloud. So again, this is where you might want to start. Is part of your business already in the cloud? And then what other services are you exploring? We'll definitely get more into this as we get deeper into these chapters. But when we're talking about services, this is really and truly the driver that is going to drive most people into either Microsoft Azure, Amazon Web Services, Google Cloud Platform, or even Oracle Cloud. There's different things that are required that would make that determination on where you want to go. And then our next question here, what do you need? What are the requirements? This is one you have to really make sure that you walk your business through. If you go in and you ask the business, what do you need? They're going to point to their data center and they're going to say, I need that. Well, I will tell you right now that I have been a part of projects, and thank goodness not in the last 7 or 8 years, but prior to that, when cloud was still even newer than it feels now, and it's still fairly new, but business people would look and you would ask them, say, what exactly do you need in your environment? And they would say, I need this. Right now I have this great big server here running, and I have this much storage, and I'm using this other stuff. And oh yeah, I have it duplicated. I have it in Virginia, and I also have it in Oregon as a backup. And if you go in and you take requirements that way, again, you will fail every time. So I have one in particular that I had an organization that was moving to the cloud. They wrote their own requirements. I came in and led the team that implemented their requirements. And at the end of the first year, they thought they were going to spend, because in their data center, they were spending about $250,000 a year. And when they got their bill, it was over $380,000 a year by the time they moved this over. And they said, we don't understand. We thought cloud was cheaper. And that's when we had to say, look, we implemented exactly what you told us to, but actually, we're sitting here looking at your servers, and when they are running at about 50% utilization. Well, people in the old world looking at their IT systems think, well, yeah, I want to run at about 50% utilization, because then when I'm really hitting my heavy times, I want to be running at about 90% utilization. And if I hit 95%, I'm going to be calling people in the middle of the night and asking them to put more memory into this server. Well, that's not the case in cloud. In cloud, you are always measuring your cost versus your performance. So you very well might want to run a server at about 95% utilization all the time. And the way we get around this is we can duplicate servers. So if we have one that's running at 95 all the time, we feel good about it. But then if it hits 99%, we very well might spin up another server to take some of that load off. And then when the other server drops back down, we might shut down that other server and take that out. And we talked about this a little bit in chapter 1. We were talking about load balancers. That's how we make this magic happen. So again, we'll still explore this subject. So don't worry. This isn't the first or last time you're going to hear about load balancers and what we do with load in order to help. But the reason I'm going deep into this conversation is to make sure that you understand that one of the questions of what do you need? What are the requirements? This is where people like us, you don't have to be the most technical of technical, but you need to be technical enough to go in and be able to recognize when the business says, I want this giant thing. You say, no, you don't. You don't want to pay for this giant thing. You want to pay for exactly what you need in the cloud. And if we need to grow, we can grow. And if we need to shrink, we can shrink. And if you follow us down this road, we can save you money. But if you go out and you reproduce your data center, you will not save money. You will spend more money than you would if you ran this in your own data center. All right, our next one, who are the key stakeholders? This is very important because you want to make sure that you pull in the people that have a vested interest. Now, we'll probably talk about this a little bit farther into the slides here, but not everybody who thinks they're a stakeholder is a stakeholder. They really have to be people that will be impacted and are accountable for this environment. So these are people that are, responsible for cost centers. Make sure that the key stakeholders are involved, and you determine this: who has a vested interest, what is their motivation, and how much influence do they have. And there's entire studies on stakeholders and how much influence they have, and there's measurements, and that's up to your project manager. Let them take care of that, but make sure that it does occur. Okay, and then now we're talking about our key stakeholders. So again, I told you it would happen in the slide or two, and here it is. Who are the stakeholders? Everyone thinks they are, but who has the power, influence, and authority? So of course, anyone in your C-suite, your CEO, CFO, CIO, CTO, CISO, your department managers, key network and application users. These are all people that are actual stakeholders and need to be involved in any decisions that you're making whenever you're trying to gather the requirements. Especially, we mentioned our network folks, they need to be at the table. You don't want to bring them in later. You want to make sure that as you're talking about the things you need, that they are there. So keep in mind, we've talked about a few things like content delivery. If you're running a content delivery organization, oh my goodness, do the network people need to be there, because they need to tell you if what you're dreaming up is possible or not. Now, a lot of times, those of us in the business side and even in the IT side, we think I have a server running in Dallas, Texas, and that's good enough. Everybody can access this server in Dallas. No, not they can't. You can't have the entire country. You can't rely on the internet backbone to drive all of that. So you need to make sure that you're making good, sound decisions and that you have your network people involved. All right, some more here. Ask the right questions. This is, we're just scratching the surface here. Of course, there's so many questions that you want to ask, but some of the knowledge that we've already gained just in the first three chapters, and I hope that you can all start to speak in terms of infrastructure as a service, platform as a service, software as a service. You want to be able to speak to those because you want to be talking to your business about that. Deals are won and killed on these types of conversations. So we'll start out talking about infrastructure as a service. This is replacing compute, storage, network. That's what that is. So it's saying you go here and instead of ordering a server, you go point and click and create an image and you deploy that image. But then we get into our platform as a service, and that's a little bit different. You're giving up control of certain things, but as you move into the cloud, you learn that that's not giving up control. That is handing over responsibility to somebody who's probably able to do that better than you are. I mean, imagine we have database administrators working at Amazon. That's what they specialize in. They do the same thing every day. They're going to be a little bit better than somebody that we know that does that with 20% of their time, and the other part of their time they're leading teams, and the other part of their time they're writing code, they're doing different things. So we know that when we move into the cloud, they have resources that we would expect to be better. And then of course, you talk about software as a service. This is the cheapest, best way to run anything. I mean, and you might debate me on that, and that would be great. And this is a debate you can have. But think about this. If you're going to spin up an email server, you have to have somebody running the operating system. So you have a system administrator making sure that that works great. And then you might have somebody else that installed the software, the email software. And they need to be around and they need to have knowledge documents in case anything happens. So they always have to have somebody on call to come in and deal with that. And so there's other pieces to that I'm leaving out. But just for simplicity, let's just say it's those two. Well, if we go with a SaaS solution, a software as a service solution, that's like going to Google Mail, using Mail. You don't ever have to call anybody. It's never down because Google has people working full time ensuring that that service is up and working. So you can run that complete. I'm not going to say free because if you're paying a corporate license, it's not completely free, but it's still so much better than paying people to be around that you may or may not need and to pay for those things. So these are the types of conversations and types of questions that we need to ask. And then finally, what framework are you going to use? What CSP will you use? These questions, there's various things that play into this framework. That's probably going to depend on which cloud service provider you use because they each have their own framework. And so whenever you make that decision, then you go back and you determine what's the framework. Maybe use a company framework, but if you use a company framework, it definitely needs to incorporate the pieces from the cloud service providers. And then finally, what CSP will you use? This one is one of the more interesting conversations because if you strictly look at what do I need out of my CSP, that's when the cloud practitioner, the people that know a lot about cloud, they start asking questions and they have different opinions and different reasons they would steer people towards a certain CSP. So I'll give you my personal view on this, and my personal view has changed multiple times over the years. So the more I learn, it requires a back and forth. But in general, I would say that if you are a single organization out there and you are spinning up a cloud environment, you would probably want to go with Amazon Web Services. And the reason I say this is because it's a lot easier to get started. There's tons of training. You can pick all that up. You can be up and running. You can get support when you need it. You don't have to have support if you know what you're doing, but then you can also pay a certain amount and get a little bit of support when you need it. Or if you want to pay a lot more, you can get support right now. So Amazon Web Services, really, really good. Oh, and then the other thing is Amazon Web Services has services out the wazoo. There's over 200 services that you can use. And we'll definitely touch on some of these services later in the, and maybe even after we complete the book material. We have lessons that we're going to go through about what all those services are and what is available. But they have over 200 services available to you to use based on your needs. Now, I said that that was what was best. If you're just a single organization and you're wanting to jump into the cloud, I would go with AWS. If I'm an larger enterprise and I am using a lot of Microsoft products, I would go with Amazon hands down. You want to, I'm sorry, I said Amazon, I meant Azure. You want to utilize the existing relationships you have with Microsoft, and it's a lot easier to implement things. Now, they're not, Microsoft Azure does have services, and I'm not trying to downplay those services, but Amazon's going to always be out there with the latest and greatest services. Microsoft's going to have more business services. And so, if that's exactly what you want to do, then that's the way you want to go. And then the final thing I will say is if you came in and you were just wanting to utilize a little bit of compute, a little bit of storage, but you're wanting to utilize a lot of Google services, hands down, go with Google. And yeah, we'll be talking about those CSPs more in the future.
So, the next thing we want to consider when we're asking the right questions: who is paying for the migrations? So, when you're looking into migrating to the cloud and the cloud migration projects, your stakeholders are very, very important. Keep in mind that pleasing your stakeholders is one of your main objectives. Um, you can question things that your stakeholders tell you, and maybe you can steer them in a different direction if you feel that there is a better direction. But also keep in mind that the people that are paying for the migration are the ones that should get what they want. So if they're asking for your opinion and they welcome your opinion and you're giving it back, that's definitely a good thing. But you also might find yourself in a situation where you are asked to go in a direction and you may not ever even know the real reason why that direction was chosen. The stakeholder may have some a reason why they're going with a certain CSP or doing things in a certain way, and so it's very important to understand who your stakeholders are, how much power they have, and what the appropriate thing to do is. And then another question we want to consider: what are the company's needs right now? So this is a lot easier in the cloud. The commitment's a lot easier on than it is on-prem. So remember, in on-prem, you're going to order a server. It'll take months to get there. When you get it, you have to rack it and stack it. And then even when the decision was made on what type of server you were going to buy, you were buying a server that you were going to grow into. So you you're buying a server that's bigger, more expensive than you need. You're buying storage that's going to be a lot larger than what you need because you're not just paying for what you are going to use. So the on-prem environment is a commitment of 5 years, 10 years. But when you're doing things in the cloud, of course, you can spin stuff up and rip it down. And then the great thing here too is, especially for storage, you don't have to buy large disk. You only pay for what you consume. And then when it comes to compute and the other things, you can spin up exactly what you need right now. And then if you need to grow, you can grow. And if for some reason you need to shrink, you have that capability as well. Then the last question that we want to consider here is: what CSP should the organization use? So this is a very interesting topic, and everybody's going to develop their own opinions. I hope that you're already learning a little bit about cloud and you're already getting your opinions. I'll share my very high level quick opinions. AWS is what you use if you know exactly what you want to build. You go out and you create the compute and you have all the networking tools. You can easily replace your data center by moving into AWS, but then you also have hundreds and hundreds of services. So you'd want to look into those and see if there were any of those services that make you want to make that decision to go with Amazon Web Services. And then with Azure, this is more geared towards people with business needs. A lot of people are already very heavily invested in Microsoft, so it makes a lot more sense to stay with Microsoft. You get your support. Also, Microsoft will help you a lot by bringing you in resources that can help you. And then if you want to go with Google, most of the time the reason you're going to make that decision is because you're going with one of the large Google projects or products that's already out there, like Google Earth Engine or some of their compute instances. There's usually a reason why people would want to go with Google. And again, it has a lot to do with their commercial presence. And then Oracle, the reason you would want to go with Oracle is if you're a heavy duty Oracle shop. If you go with Oracle Cloud, you definitely can get the best pricing for Oracle products. They offer compute. They offer the same things that the other CSPs do, but really for the most part, if you're going with Oracle Cloud, it's because you're heavily invested in Oracle. The next thing we're going to start talking about are the different cloud adoption frameworks. So a framework, if you're not familiar with the term, it's a term that's been in IT for a number of years in business. And what it is, it's a rule book. It's something you can follow. It's designed to help you get started and to know where to start and what's next. And each of the CSPs have their own framework. They're all, kind of similar, but you can see the differences in them and the way that the CSPs put them out there and documented them. And what it is it's them trying to say, if you want to implement our product, this is a way to do that. Now, some more advanced companies have already developed their own frameworks. But what we're going to look at here over the next few slides are the frameworks that were put together by the CSPs. So if you'll click there on that first link, it's going to take you to this PDF. It's a 42-page PDF. And then we're going to go down to page 6. This is where it starts with the English version. And you can read here, and all of these items are clickable, and it's a great way to come in here and start learning about how are we going to adopt the cloud. So we have our AWS well-architected framework. This is an AWS tool that's designed to let you know what you're trying to do, what type of compute instances you're doing, and it's making sure that as you implement it, that you do it in a well-architected way. So here, their definition helps you understand the pros and cons of the decision you make when building systems in the cloud. It also includes the 6 pillars. Now, you don't need to know the 6 pillars, and you don't even need to know about AWS for this particular certification. But after you get this certification and you decide to really do a deep dive into one of these CSPs, that's when you're going to need to decide which one you're going to tackle first. And then you'll dig in here, and each of them come with the things some different pieces of information that you will need to know. So then the next thing, and that next on there is this link to this video. So we're going to click this video. It's 2.5 minutes here on the AWS Cloud Adoption Framework.
Hey, this is Andrew Brown from Exam Pro, and we are taking a look at the Cloud Adoption Framework. So this is a white paper to help you plan your migration from on-premise to AWS. At the highest level, the AWS CAF organizes guidance into 6 focus areas. We got business, people, governance, platform, security, and operations. And this white paper is pretty high level. So, it doesn't get into granular details on how that migration should work, but gives you kind of a holistic approach. And I believe that probably through the AWS Amazon Partner Network, there's people that specialize in using this particular framework to help organizations move over. And I believe that AWS has professional services through the APN. But let's just kind of break down what these 6 categories are. We're not going to go too deep into this, but let's do it. So the first is the business perspective. So these are business managers, finance managers, budget owners, strategy stakeholders. So it's how to update the staff skills and organizational processes to optimize business value as they move ops to the cloud. You have people perspective, so human resources, staffing, people managers. So how to update the staff skills and organizational processes to optimize and maintain the workforce and ensure competencies are in place at the appropriate time. You have governance perspective, so CIOs, program managers, project managers, enterprise architects, business analysts. So how to update the staff skills and organizational processes that are necessary to ensure business governance in the cloud and manage and measure cloud investments to evaluate the business outcomes. We have platform perspective, so CTOs, IT managers, solution architects. So how to update the staff skills and organizational processes that are necessary to deliver and optimize cloud solutions and services. Security perspectives, so CISO, IT security managers, IT security analysts. So how to update the staff skills and organizational processes that are necessary to ensure that the architecture deployed in the cloud aligns to the organization's security control requirements, resilience, and compliance requirements. We have operations perspective, so IT operations managers, IT support managers. So how to update the staff skills and organizational processes that are necessary to ensure system health and reliability during the move of operations to the cloud, and then to operate using agile ongoing cloud computing best practices. So this just taps the surface of what the CAF is. And I think for each of these, they actually have a more detailed breakdown. So, business is going to break down to even more finite things there, okay?
So
The next cloud adoption framework we're going to look at is the one from Microsoft Azure. So they have a very similar way to attack this, but you'll see it's slightly different. It's a little bit geared more towards business. It has stakeholders and outcome and business drivers. So let's jump over to our web page, take a look. So if you follow that first link, you're going to come here. And as you can see, Microsoft has broken this down into their guidance areas. So if you're just getting started, you can click right here and get to very high level. Then you can dig deeper into like the strategy, the plan, ready, migrate, innovate, secure, manage, and govern. So they give you all of these breakdowns. And again, the intent here is that you grab this, you pull it down. If you have nothing, you start with this, and then you start catering it to your organization. So now we're going to watch a short video here from Microsoft on them describing their cloud adoption framework.
In this lesson, I want to describe the cloud adoption framework. Now, we've covered a lot of different governance things, tagging and policy and RBAC and much, much more. And if I'm starting out, or maybe even experienced, it might be intimidating. Well, what should I be doing? What are the best practices? How do I think about the steps to be successful in the cloud? So cloud adoption framework is a set of best practices about adopting the cloud. And it's easy to just go and look at the cloud adoption framework site to get a gist of what it's doing. Now, I would recommend go through this starter page, look at the video, and understand really what it's focused around is this idea of a life cycle. We're going to define our strategy, and there's various things that are going to drive what is our strategy, our business plans, our projects. Then we're going to plan. Well, there's skills we have to get. There's plans for adopting the cloud. We have to set up Azure, set up landing zones, expand it, apply best practices, migrate resources to Azure, maybe innovate around Azure. There's a whole set of different things that we're going to want to do. And then there's an ongoing governance and management of it. So Cloud Adoption Framework has these key stages. So understand those stages. Understand its design is really just about, well, how do I get a best practices cloud adoption? And that's what this is really all about. So again, my recommendation here is to just go through this starter page. I would just kind of watch the overview video. You could look at this idea of the strategy and just these very basic things. You don't really need to understand more than that, but just have a basic understanding of what that cloud adoption framework is, and you should be in good shape.
So again, either one of these are a great place to start. Of course, if you are using Amazon Web Services, it's best to start with the AWS Cloud Framework. If you're going with Microsoft Azure, you can start with the Azure one. But as you start to implement these, you might take the best of both and utilize it whenever you're building your own cloud adoption framework within your own company. And as we migrate through the section here on using our cloud assessments, a couple more things that we do want to consider is using baselines and running feasibility studies. So when you're using a baseline is a test that captures performance data for a system. For example, network administrators establish a baseline for a server's central processing unit or CPU usage. random access memory, RAM, usage, and then network throughput and hard disk data transfer speed and storage utilization. Kind of the same way as if you hit Control-Alt-Delete on your laptop and then go to Task Manager, and you can look and see how your performance is going right now. So think of it like this way. Say that you are wanting to buy a new laptop. So you start running through and doing your normal workloads. And then you go to the task manager and you check and see where you are. You see how much of your RAM you're using, how much of the CPU, what the network usage looks like. And then you bring in your new laptop and you do the same thing. You run the same things and you go look to see how much better the new laptop is running. Well, I know that's a simplified version of this, but think about this. Without the baseline, you would not know if you're performing better or worse than you were. You can't just go with the way it feels. You really need to have a baseline so that you can measure those things and know that whenever you make a change, if it's actually better or worse. And again, if it's worse, then you start tweaking things and you make sure that the new system, it performs better than what the old system did. And then the next one here, running a feasibility study. So you do the future requirements, do the future requirements require the cloud? Does the company have the ability to migrate to the cloud? What capabilities can and should be offloaded to the cloud? What are the company's needs? What is the migration path? So whenever you run a feasibility study, this is extremely important because this is when you ask questions such as, do we have the right people? Do we have the people here that are able to help us? Can we utilize the existing staff, but maybe we need to hire somebody in that has the skill set? Maybe we need to get the teams trained. This is where you come up with these types of requirements to make sure that you are going to be successful in your cloud journey. And then that also includes the rest of these, like what are the compliance needs? If you're processing credit card payments, of course, you'd want to make sure that your PCI requirements are in there. If you're doing government work, you may have some things that you need to think about. And of course, if you're in healthcare, you'll have your HIPAA requirements. So the cloud, all of the CSPs are very, very helpful in making sure that you do meet whatever compliance needs you have, but you need to do the study so that you know which ones to be looking out for and what to plan for. And then, of course, your migration path. You need to decide, is this a lift and shift, which is kind of a bad thing? I mean, unless you just absolutely have to. Most of the time you want to do something like a lift, tinker, and shift, or there's other plans where you decide, as we migrate into the cloud, what are some things we can implement to really start taking advantage of being in the cloud? Next thing we may want to look at here is conducting a gap analysis. So with this, we use the baseline and feasibility studies to contrast and compare. We prioritize the allocation of resources, identify technical features left out, determine the compatibility issues, and then identify the policies or regulations. So right here is a little spreadsheet example of a gap analysis template. And so you want to look at the things and include the categories of like business, people, governance, platform, security, and operations. And what you're doing here is making sure that you're measuring the distance between where you are now and where you want to be. So that's the reason we'd want to do this gap analysis. And then another reason we do this is because we want to refer back to it as we're working, and when we're done, we want to make sure that we're reaching our goals. The next thing we want to look at when we're talking about our using cloud assessments, we want to use reporting to identify our metrics. This kind of goes back to our compute, network, storage, and services, and anything else that we're going to be looking at. We want to use reports. We don't want to just use eyes on the screen, so that we have something to refer to, because we want to make sure that we're taking out as much of the human element as possible. So we run our reports, we compare them, through different areas of the project, and with hopes that when we move into the new cloud environment, that everything that we wanted to happen. We want that the performance to be better. So make sure that you're doing those using reporting. And then the next thing here are understanding the benchmarks, availability, response time, and incident resolution time. And the next thing we want to look at here is this is all within the creating documentation and diagrams. So documentation is very important. I've already alluded to this multiple times, but you need to document everything, including conversations with stakeholders and team members, the location of all resources and applications, owners of capabilities and processes, internal and external points of contact. I know that I lead several large projects, and I always make sure that I keep track of who said what. And a lot of times I'm taking down notes and I'm doing it in front of them, and I try to send them out weekly so that everybody knows that what they're saying is being recorded. And it's a great way too, if I'm understanding something differently than the way the intent of the speaker, then they will let me know right away as I'm documenting it. They'll say, no, that's not exactly what I meant. So it's a very useful tool. And then it's also a way to protect yourself, to make sure that, if you're on the IT side and you're building up the system, if the business is going to come back later and say, well, you didn't build what we wanted, then you have something to go back to. Say, well, right here's where I documented this. I sent it to you on this date. This would have been the time to correct that. It's a little late now. So again, just a little bit of project management mixed in here with things that you want to look out for. And then the last thing they included here in our book is some collaboration tools. So we'll start down at the bottom, Win.io, TimeCamp, and the planner function, Flock, Slack, and then finally I'll go to the top here with Microsoft with their Teams and group chat. And Teams really ties everything together. Microsoft Teams is not just a chat tool. It is a great chat tool. As a matter of fact, it's replacing a lot of phone systems. People are no longer calling people on their desk phone. Usually their phone number is now attached to a Teams ID. So if somebody calls you, it just rings on your Teams. Your voicemail is on your Teams, and it keeps it all right there in one place. But then in addition to that, Teams allows you to do these other applications within Teams. So you can have OneNote, OneDrive, SharePoint, all of your Microsoft products. And then you can also buy plugins for others. And it's a great way to manage your projects all right there within the Teams. And then you also have, you can assign people to the team. You can grant access to certain areas for the people that need to have access to some things. And then you can grant access to other areas. So it's a great restriction all around team collaboration tool. Here's a little call out that our book pointed out, and so I wanted to bring it into a slide. But as a reminder, for the Cloud Essentials Plus exam, you need to know how to use the appropriate cloud assessments given the scenario. So here are the ones that you want to be familiar with, and these are the ones that we just went over, but here it all is in one slide, and then also I'll show you in the exam essentials we capture it in another way for you to be able to study it and remember it. But it includes current and future requirements, baseline, feasibility study, gap analysis, including business and technical, then reporting. Our book points out that's compute, network, storage, of course, benchmarks, documents and diagrams, key stakeholders, and points of contact. Okay, so that brings our first section to an end. So now we're going to start a brand new section. So if you haven't already, hit pause on this recording and go through and read pages 90 through 117. That's the end of the chapter, and it's all around understanding the cloud services. Okay, in our next section, we're going to be talking about our cloud services. So there are lots and lots of cloud services. We always talk about our big three things that we need to replace our data center. We need compute, we need storage, and we need networking. So with those things, we can do just about everything that we do inside of our data centers. We can create virtual machines, we can install software on the machines, we can run the software. So really those three things has us covered. But then when you're in the cloud, you have all these other services. And when I say services, I mean lots and lots and lots of services. When I first started getting exposed to Amazon, they had almost 100, and now they have over 200. Microsoft, the same thing. They have all of these cloud services, and they just get better and better and more focused And so as time goes on, these services are taking over, the cloud world. And we'll have more conversation about that whenever we talk about the future of cloud. But when you can do something within a service instead of spin up a server and do instead of spinning up a server and doing it yourself, you're doing things more efficiently, more cloud native, and so things just work out a lot better. So the ones we're going to look at here over the next few sections: identity and access management, multi-factor authentication, single sign-on, federation, cloud native applications, microservices, containerization, data analytics, artificial intelligence, machine learning, digital marketing, Internet of Things or IoT, blockchain, subscription services, collaboration, and VDI. So the first one we're going to look at here is IAM, or Identity and Access Management. This is how we access the system, who can access the system, and what they can do once they get there. So this gets more and more complex, but at its simplest form, when you first sign in and you order an account, one of the first things you're going to do is you go in and you create users. And then once you create users, then you might get a little more advanced and create groups. And then you can put the people in the groups. And then you have, within these groups, you assign the policies so that you can determine what those people do. So for instance, let's say I have a group of administrators that I want to be able to do just about anything. I create a group called administrators. I create the policy to let it do everything that I need it to be able to do. And then I assign users to that group. So if you're a user, you walk in the door and they say you're an administrator, you can do all of these things. But then if somebody removes you from that administrators group, you can now no longer do those administrative tasks. So again, that's at its very, very simple form in the way that we usually start out when we first start working in the cloud. All right, our next service that we're going to talk about is MFA, or multi-factor authentication. So within multi-factor authentication, it is something you know and something you have, somewhere you are. So for years and years, we just use passwords. But then, as you know, and multi-factor authentication has come around, and you probably have all seen it, like on your bank sites and other sites, where it's going to ask you some question after you do your password that requires you to have something, or it's going to make you click something on your phone. Or a lot of the Google apps will open up a Google product on one of your devices and you have to go there. So the thought process here is somebody might have your password, but they shouldn't have your device as well. So again, it's always something you know and something you have, or somewhere you are, or some other factor of authentication. Or something you are. So some examples here, like PIV cards, tokens, phones. So right here, this is the RSA token that most people started out with. You would have this token, you can see it on people's keychains, and this little code runs down. Here was the timer. So you'd plug in your password, and then you had to also plug in this code. So the thought here is you're plugging in your password, but you for sure had to have this device with you in order to be able to plug that next number in and give a little bit added value. Now, these tokens have kind of been replaced with soft tokens. Look something like this that's on your phone. And so, all the CSPs have their own versions of these tokens. And they look something kind of similar to this, where there's a code that is rolling and changing so that you always have to be able to have access to that device. Next one here, single sign-on. So this gives users access to all systems using one username and password. So one simple example of this is like your Facebook password. So you're on your computer and you're on Facebook, but then you pick up your phone and you go there. It's the same username, same passcode on the phone. And then another application like Messenger, use the same username, same password in order to gain access to that. So you only have to remember one password for a multitude of applications. So that's a simple commercial use, but people that have things in the corporate world, and that they're more apt to understand that you have like maybe 30 systems and the username password is the same on all of them. The next thing we want to focus on here is federation. So as I mentioned, when you first start out and you're doing your identity and access management, you're probably just doing users, groups, policies, and at a very small level. But then when it gets bigger and it's a lot more involved, you don't want to be in the CSP making those changes on every single person. So you're probably going to use something called federated access. So federation is the way that we use another system to federate into our cloud system to provide the structure that we need. So some examples here: Office 365. It's also called FIN, or Federated Identity Management. And so Active Directory is the one that we're probably the most familiar with that we use. Active Directory houses all of the information on every individual in the company. It has the corporate org chart, and it also has groups. So you can grant groups within your Active Directory access to certain things and restrict access with others. And so within that Active Directory, you have users, groups, and roles. All right, in this next section, we're going to look at a few things that wouldn't exist outside of the cloud. So we call these our cloud native applications. So some applications were developed with cloud concepts and would not exist outside of the cloud. So two we're going to talk about in a little more detail are microservices and containerization. So with microservices, this is a way that we pull little bitty pieces of functionality that we use within an application, or more likely, we use it in multiple applications. And we pull it out of the applications and we place it somewhere independently. And we have all the applications call that microservice. So there's lots and lots of reasons why this is a good thing. For one, we don't stand a chance of having old bad code sitting around in our old applications. Instead, it's just a call to this function, and this function or this microservice sits out here. And if we make an update to that microservice, everybody gets it. So a very simple example of this would be like, let's say that we have a phone number. So you send an employee ID and it brings back the phone number of that employee. So we put that call in all of our applications, and then within the microservice, it sits out here. And the microservice's job is to wait for the call to come in, and it says, here's an employee ID, return the phone number. Then it goes out, grabs the phone number from wherever it's stored, and it brings it back, and then it delivers it to that application. So think of all the benefits of having a microservice. Let's say you improve the way that you can look up phone numbers. You can now do it so much faster than you used to be able to do it because you changed the database or you did something on the back end. You don't have to go make those changes in all of your other areas. So microservices are really growing in popularity, and it's almost become a necessity to ensure that we don't have applications performing functionality, duplicate functionality across the board, and it improves the microservice. So the definition here: monolithic applications used to be part of the same file. These were broken down into smaller components. So right here's the example. So monolithic, we had this app and it had all of this functionality in here. So the user comes in here, it's running, and then this would be multiplied. So you had this in several different areas. Very, it's fine if nothing changes, but you have all this duplicate data, duplicate functionality. And then right here, we have it broken down into a microservice. So the user interfaces with the system somehow. And then right here, it calls the microservice. And then the microservice goes out, performs the function, returns the call, and then brings it back in. And then the next thing that we're going to talk about here is containerization. So it's just like it sounds. It's items being placed inside a container. So we'll watch this video here in just a minute and let IBM describe containerization. But the way I will describe it to you is, let's say that we have a web server and an application server, and they work together. And then if we duplicate, like if we have a function to where if we have 5 users, we're running in one system. And then if we get 10 users, we need to duplicate that system so that we can handle the workloads. doing it server by server works, but it's a lot better to do it if you're going to do all the things that you need and all of the things that you need inside that container. And then that way you duplicate the container instead of duplicating individual services or servers, I'm sorry. And again, that's a very simplified version of that. But then with this, I have to bring out one of my favorite Dilbert cartoons here. Because there's a couple of different containerization tools. One of them is called Kubernetes. One of them, there's some others. There's one called Dockers and some different tools. But one of the bigger ones is Kubernetes. So here the pointed hair boss says, I need to know why moving our app to the cloud didn't automatically solve all of our problems. And then Dilbert says, well, you wouldn't let me architect the app to be cloud native. And boss says, well, just put it in containers. And he says, you can't solve a problem just by saying techie things. And the boss goes, Kubernetes. This is a conversation that kind of plays out. I've seen it in some very large programs where people duplicated what they had in their data centers in the cloud and then came back and said, I don't understand. Things aren't running better and it's more expensive than it was. And we have to go back and say, well, you did not architect your application to take advantage of the cloud. You have to know what the cloud is good at, and you need to put in some things to make it actually work better and cheaper. So let's jump in here and watch this video from IBM.
Hi everyone, my name is Cy Benham, and I'm a developer advocate with IBM. Today, I want to talk about containerization. Whenever I mention containers, most people tend to default to something like Docker, or even Kubernetes these days. But container technology has actually been around for quite some time. It's actually back in 2008 that the Linux kernel introduced C groups, or control groups, that basically paved the way for all of the different container technologies we see today. So that includes Docker, but also things like Cloud Foundry, as well as Rocket and other container runtimes out there. Let's get started with an example, and we'll say that I'm a developer and I've created a Node.js application, and I want to push it into production. We'll take two different form factors to kind of explain the advantages of containerization. So let's say that first we'll talk about VMs, and then we'll talk about containers. So first things first, let's introduce some of the things that we've got here. So we've got the hardware itself, just a big box. We've got the guest, or rather the host operating system, as well as the hypervisor. The hypervisor is actually what allows us to spin up VMs. Already, let's take a look at this shared pool of resources with the host OS and the hypervisor. We can assume that some of these resources have already been consumed. Next, let's go ahead and take this JS application and push it in. And to do that, I need a Linux VM. So let's go ahead and sketch out that Linux VM. And in this VM, there's a few things to note here. So we've got another operating system in addition to the host OS. It's going to be the guest OS, as well as some binaries and libraries. So that's one of the things about Linux VMs, that even though we're working with a really lightweight application, to create that Linux VM, we have to put that guest OS in there and a set of binaries and libraries. And so that really bloats it out. In fact, I think the smallest Node.js VM that I've seen out there is 400 plus megabytes, whereas the Node.js runtime and app itself would be under 15. So we've got that. We go ahead and let's push that JS application into it. And just by doing that alone, we're going to consume a set of resources. Next, let's think about scaling this out, right? So we'll create 2 additional copies of it. And you'll notice that even though it's the exact same application, we have to use and deploy that separate guest OS and libraries every time. And so we'll do that 3 times. And by doing that, essentially we can assume that for this particular hardware, we've consumed all of the resources. And there's another thing that I haven't mentioned here, but this JS application, I developed it on my MacBook. So when I pushed it into production to get it going on the VM, I noticed that there were some issues and incompatibilities. This is the kind of foundation of this big he said, she said issue where things might be working on your local machine and work great, but when you try to push it into production, things start to break. And this really gets in the way of doing agile DevOps and continuous integration and delivery. That's solved when you use something like containers. It's a three-step process when kind of doing anything container related and pushing or creating containers. And it almost always starts with first some sort of a manifest. So something that describes the container itself. So in the Docker world, this would be something like a Docker file. In Cloud Foundry, this would be a manifest YAML. Next, what you'll do is create the actual image itself. So for the image, if you're working with something like Docker, that could be something, there'll be a Docker image. If you're working with Rocket, it would be an ACI or application container image. So regardless of the different containerization technologies, this process stays the same. And the last thing you end up with is an actual container itself, that contains all of the runtimes and libraries and binaries needed to run an application. That application runs on a very similar setup to the VMs, but what we've got on this side is, again, a host operating system. But the difference here, instead of a hypervisor, we're going to have something like a runtime engine. So if you're using Docker, this would be the Docker engine. And different containerization technologies would have a different engine. Regardless, it's something that runs those containers. Again, we've got this shared pool of resources, so we can assume that that alone consumes some set of resources. Next, let's think about actually containerizing this technology. So we talked about the three-step process. We create some, a Docker file, we build out the image, we push it to a registry, and we have our container, and we can start pushing this out as containers. The great thing is these are going to be much more lightweight. So deploying out multiple containers, since you don't have to worry about a guest OS this time, you really just have the libraries as well as the application itself. So we've scaled that out 3 times, and because we don't have to duplicate all of those operating system dependencies and create bloated VMs, we actually will use less resources. So choose a different color here, and scaling that out 3 times, we still have a good amount of resources left. Next, let's say that my coworker decides, hey, for this JS application, let's take advantage of a third-party, let's say a cognitive API to do something like image recognition. So, let's say that we've got our third-party service, and we want to access that using maybe a Python application. So he's created that service that accesses that third-party APIs. And with our Node.js application, we want to access that Python app to then access that service. If we wanted to do this in VMs, I'm really tempted to basically create a VM out of both the JS application and the Python application, because essentially that would allow me to continue to use the VMs that I have. But that's not truly cloud native, right? Because if I wanted to scale out the JS but not the Python app, I wouldn't be able to if they were running in the same VM. So to do it in a truly cloud native way, essentially I would have to free up some of these resources, basically get rid of one of these VMs, and then deploy the Python application in it instead. And that's not ideal. But with the container-based approach, what we can do is simply say, since we're modulars, we can say, okay, just deploy one copy of the Python application. So we'll go ahead and do that. There's a different color here. And that consumes a little bit more resources. And then, with those remaining resources, the great thing about container technology, that actually becomes shared between all the processes running. In fact, another advantage, if these container processes aren't actually utilizing the CPU or memory, all of those shared resources become accessible for the other containers running within that hardware. So with container-based technology, we can truly take advantage of cloud-native-based architectures. So we talked about things like portability of the containers. We talked about how it's easier to scale them out. And then overall, with this kind of 3-step process and the way we push containers, it allows for more agile DevOps and continuous integration and delivery. Thanks for tuning in for this broad overview of container-based technology. As always, we're looking for feedback, so definitely drop a comment below and be sure to subscribe to stay tuned for more videos in the future. Thank you.
The next area that we're going to look at for services are some of our data and analytics services. So first of all, we're going to watch a quick video here on what's the difference between a database, a data lake, and a data warehouse. And I'll tell you from my experience, used to when we'd run these really large applications in the mid to late 90s, every application would have a database. And then we started trying to want to go in and dig into that data and do some things with it. And we determined that it would impact our applications. So we started pulling that data out and just copying it elsewhere. And we would call that the data warehouse. And then we would pull data from different applications, put over here so that we could run queries and we could beat up that data warehouse and it would not impact performance of the application or the users. And so that's when I started learning about databases and then moving things into the data warehouse. And then, of course, data lakes now have come along and they have a little bit even broader function here. So let's watch this quick video here on what is the difference between our databases, data warehouses, and data lakes.
What's going on, everybody? Welcome back to another video. Today, we're going to be taking a look at the differences between a database, a data warehouse, and a data lake. Now, when I was first starting out, I had only ever heard of a database, and I think that's what most people are familiar with. But I had never heard of a data warehouse or a data lake. And so in this video, we're gonna be walking through the differences between each one of them, as well as how they kind of connect with one another. So let's jump onto my screen and get started. All right, so we're gonna be taking a look at a database, a data warehouse, and a data lake, but let's start with a database. Now, when someone says a database, typically they're referring to a relational database. Now, a relational database can capture and store data via an OLTP process, which stands for online transactional process. So when a company completes a transaction and sells an item, it'll record that within a database. And that data has the ability to be live real-time data. Data in a database is going to be stored in tables, which has columns and rows, and it's going to be highly detailed, which means you're going to be able to go in and see every single aspect of the data. And databases also have a really flexible schema, which means you can go in there and kind of change things as you go to make it work for what you need. Now, a data warehouse is also a database, just like we were looking at before, but it's going to be used for analytical processing, or OLAP. OLAP stands for online analytical processing, and it's created to basically analyze huge amounts of data. Now, if you notice on the last slide, there were these three databases, and they were just kind of sitting there and they were storing the data. In this visualization that we have on the right, these three databases on the bottom are all aggregating and sending their data to this data warehouse via an ETL process, which is where it extracts the data, it transforms it, and loads it exactly how they need it in this data warehouse. And that's how data is put into the data warehouse. It isn't getting it directly from the source, but it's being put into a database, and via the ETL process, it's being updated as it goes or whenever the ETL process runs. A data warehouse will always have the historical data, but it won't always have the current data unless the ETL process is running every single day or very frequently. The data in a data warehouse is also a little bit different because we're doing this ETL process to get the data in there. We're not actually putting every single piece of data or every column and row in there. We're typically summarizing it and then putting it in there, which will allow us to process that data for our analytical purposes much faster. Now, a data warehouse is going to have a much more rigid schema, so you really need to plan ahead with how you're going to put your data into a data warehouse. It's not as flexible as just a database. So now let's look at some of the key differences between a database and a data warehouse. A database is going to be used for recording transactions, where a data warehouse is going to be used for analytics and reporting. A database is going to have fresh and detailed data, where a data warehouse is going to have summarized data, and it's only going to be as fresh as the ETL process is created. A database is going to be a little bit slower for querying large amounts of data, and when you do query large amounts of data, it can actually slow down the processing of all those transactions. A data warehouse was designed for the exact opposite. It was designed to be very fast at querying and not slow down any processes, because it isn't part of that transaction processing at all. So now that we've looked at a database and a data warehouse, let's take a look at a data lake. A data lake was basically designed to capture any type of data that you could possibly want. It could be a video, a picture, an image, a document, a graph, anything you could imagine that you'd want to put in a database or store in some way, you can store it in a data lake. Now, there are a ton of use cases for a data lake, but I think people who work with machine learning and AI get to use it or benefit from it the most. They can use all that structured and unstructured data and create models to really use it in its raw form, where if you want to use it for analytical purposes, typically you're gonna have to clean it up a little bit and do a little bit more work to actually make it usable. And so a data lake is just that. It's this lake where you can basically throw any type of data in there, but it's not always super usable because you're just putting it in there in its raw form. If you want to use it for analytical purposes and reporting, most of the time you're going to want to clean that up and put it into a database or a data warehouse. So now when we're looking at all three, they are all different and they're all used for different purposes. So no one option is better than another for your data. If you're using it just to record transactions, a database is what you should do. And if you have a large amount of data that's just too much for your database to handle, sounds like you might need a data warehouse. And if you have all this data, you have no idea what to do with, or it's unstructured, it's semi-structured data that you can't fit into a database, well then I highly recommend using a data lake. There really is no one size fits all. All three of these can be options for different uses. And in fact, you can use all three within one company for just different things that your company needs. So I hope that that was helpful, learning the differences between a database, a data warehouse, and a data lake. Again, I had really never used a data warehouse or a data lake when I first got into analytics, but now that I've gotten hands-on experience with all of them, they're all really interesting, can be used for so many different things. So thank you so much for watching this video. I really appreciate it. If you like this video, be sure to like and subscribe below, and I'll see you in the next video.
The next area we'll discuss here is our data analytics. Progressed to where it is today. We have artificial intelligence using virtual assistants, video games, digital marketing, financial industry, and transportation industry. And then we have machine learning, which is a little bit higher level, or not higher level, but more detailed and takes it another step farther. It's different in AI. AI is the machine needs to be programmed to respond to stimuli to complete a task. But with machine learning, the idea is the data can be fed into the machine and it will learn from it and adapt. So machine learning is a specialized form of AI. And some of the things that we can do with that are like facial recognition, speech recognition, medical diagnosis, financial modeling, prediction models, and data extraction. Another thing that we can do as a service is digital marketing. So with digital marketing, this is like email campaigns, social media, like YouTube, Facebook, Instagram, Twitter, X, Pinterest. Why? It's a better customer engagement and response, real-time results, enhanced analytics, campaign automations, and a lower cost. The next area we'll discuss here is Internet of Things, or IoT. So IoT network devices give internet presence to real-world items. So some of the very first times I ever heard about IoT, it was with somebody I knew that worked at Caterpillar. And he said that they were using IoT to make sure that a bulldozer or a digger couldn't dig into the ground where there were fiber lines, gas lines, or things. So it was built to protect those. So it's kind of neat to think that you're giving a real world item a presence on the internet. Some other examples are things like garage doors. Nowadays you can hardly even buy a garage door opener that doesn't have this device so that you can check your phone and see if your garage door is shut or closed. So it's giving your garage door this presence on the internet so that you can check it. Is the door shut and I want it to be open? Hit a button and I'll open it. Is the garage door open? I hit a button and I can close it. So other things that are IoT, home entertainment system, we just mentioned garage doors and security systems, heating and cooling devices, home appliances, modern cars, fitness and health monitors, commercial medical devices, transportation infrastructure. One of the reasons I like to discuss IoT with students so much is I feel like this is one area that even though there are lots and lots of products out there, we probably still haven't even identified half of them. And one of the reasons I know this is true is I have a friend that works at a company that does nothing but take people that have ideas around IoT and they help write the code and build these devices. And they sustain a full company. And I know of at least 2 or 3 companies like that around just in Kansas City. So there are still lots and lots of ideas out there. So if you're looking for that one really good idea, consider thinking about IoT. There's a lot of things that haven't been done yet and a lot of potential in that area. few more items here on Internet of Things, some potential issues. There's standards and governance around it, data security and privacy, data storage and usage. I consider this a lot because I have these cameras that are in my home or pointing out of my home. And I'm not too worried the whole world can have access to them. I don't have them pointed at anything really, really important. But it is kind of weird when you think about having these devices and knowing that, the security isn't 100% and that people could be looking through them. And, if you have them in an area of the house, people could, not that you would hope nobody's out there listening to them, but they do have microphones on them, and that capability is there. So there are definitely some potential security issues, even at a commercial level. Some IoT new ideas. What are some ideas that have not been developed yet? Again, I was just talking about that, how there's still lots and lots of ideas that people are still having. And I think for a while, IoT is one of those industries where if you have the really good idea, you can get people to help you build it. And there's still lots of potential out there. Here in this real world scenario, it's talking about how a vast majority of adults carry at least one electronic device with them at all times, whether it's their smartphone, smartwatch, fitness monitor, and because how common they are and potential benefits, lots of kids also have these. And so this real world case was talking about how in 2017 there was a security flaw on certain smartwatches specifically made for children. The flaw allowed hackers to identify the wearer's location, listen in on the communication and things that were going on around them. So, with most technology, there's opportunity for bad guys to do bad things. So something that we do want to consider whenever we're thinking about our new ideas with our Internet of Things. And some more services here. Blockchain. Everybody's heard of blockchain, mainly because of Bitcoin. But blockchain is defined as an open distributed ledger that can securely record transactions between two parties in a verifiable and permanent way. You may or may not have heard about blockchain, but it's like you've heard of the most famous example of blockchain, which is Bitcoin. So I want to point out that these are in your slides and you can click on these. I am not going to spend class time going through blockchain, but if you do want to know more about it, here's a 7-minute video, and then here's one that really, really goes into detail of what it is and how it works. But some of the things around blockchain, the principles: decentralization, no one owns it. It's not centrally located. Transparency, everyone in the blockchain has access to all of the data in it, and it cannot be tampered with. And then the immutability, it's unchangeable. So it's a ledger that you can add to, but it cannot be changed. So here's a little more detail on this. You can follow along here. 1, someone requests transaction, such as by making a purchase from a company that accepts Bitcoin payments. And then 2, the request transaction gets sent to the peer-to-peer network of computers called nodes that participate in the blockchain network. Then 3, using the shared logarithm, the nodes validate and verify the transaction. This essentially means solving an encrypted mathematical problem, and the process can take a few days. Small transactions need to be verified by only 1 or 2 nodes, whereas large ones need to be verified by at least 6 nodes. Then 4, after verification, a new block containing the transaction information is added to the end of the blockchain ledger. This is done in a way that makes the data immutable, permanent, and unalterable. And then 5, each party in the transaction is notified that the transaction is complete simultaneously in the new blockchain ledger with the new block. It's transmitted to all the nodes on the peer-to-peer network. Okay, so we've talked about quite a few of the services. And again, I always ask you to think of the big 3. Sometimes it's called the big 4. Some books refer to it as big 4 because they put databases in. I still think that we probably should leave databases in the service category. But you have compute, storage, network. With that, you can replace everything you have in your data center. And then, of course, you can add databases on top of that. But then everything else that the cloud service providers have to offer are services. And so services, lots and lots of services, but they can be offered in two different ways. You can do subscription services where you subscribe to it and you use it as much as you want or within a range. And then you also have pay as you go, where you use it and you just pay for the services that you consume. Some examples of this are like Office 365 and Google Docs. So again, just two different ways to pay for these services. And then the next thing we're talking about in our services, collaboration. It's always important, but as firms go global, more and more people work from home. Collaboration software is more and more important. So these things have always been important, but of course, when COVID kind of happened and people started working at home more, and a lot of people never did go back into the office. So there's lots of need for collaboration. Also, just the fact that we're global. We work with people from all over the world and we work together. It doesn't matter where you are. So some of the services that are out there that help us do this: shared file storage, video conferencing, online chat, task management, real-time documentation, document collaboration, and then Microsoft Teams, as I've mentioned before, is kind of on the bleeding edge of this, bringing it all together so that we can use all of our collaboration tools in one centralized location. Here's another service that's getting bigger and bigger. It's Virtual Desktop Infrastructure, or VDI. So it's been used since 2006. It predates the cloud, but with the cloud, it makes it even easier. So what this is it's a desktop as a service. So there's so many different use cases that make this a really great tool. So think about say you hire a bunch of people at the end of the year to help you with higher call volumes between Thanksgiving and Christmas. And so you hire these people, you need to give them a desktop. Let's say you had to hire 500 people. Well, sending out 500 laptops is a big endeavor. You have to have somebody build each one of the laptops, test them, send them out. Some of them are probably going to be flawed in some way, have to be mailed back. But if you have people use a virtual desktop, you give them an address, they sign into it from whatever device they want, and they can access their desktop. And if there's a problem, you can fix it right away and redeploy it. And so you can have these people use this. And then at the end of the season, instead of having to track down and ask that they mail back machines, you can just shut them off. So that's one simple use case. But lots and lots of different use cases. And again, it's something that just happens more and more. I work for several government entities and they give me a virtual desktop image instead of a desktop. It helps me because I don't want to have a bunch of different desktops here at my desk. And it helps them in that if they ever need to cut my access, it's very easy. They could cut it even if I had a laptop. But this way, they don't have to say, hey, Jeff, we're cutting your access. Send us back the laptop. They can just sever that access and not have to return any kind of equipment. So here's kind of how it works. So the hypervisor virtual machine. So here we have virtual desktops here, and they're all running on top of the hypervisor. Out here, the user is either on their desktop, a laptop, mobile. You can use any kind of device to access that, and it's as powerful as the machine running over here. It doesn't matter how powerful this machine is. So you can be on an iPad over here, but working through the connection broker and on one of these desktops and have access to a very, very powerful, robust desktop. So in summary, we've talked about lots and lots of services and lots of different things, but we were really just talking about three major areas. We were talking about the business principles of the cloud. Then we talked in detail about cloud assessments and how to do that. And then we went into the cloud services. And remember, the cloud services is just I'm going to say never ending list. There's Amazon touts over 200 services now. And they're everywhere from machine learning, AI, IoT, Bitcoin, VDI, and hundreds of services. Okay, now we're going to do our exam essentials. And remember, these are kind of our flashcards. These are the things that we need to know in order to be able to take the exam. It's a great place for you to come and look and see if you understand everything. If you don't, this is where you know what areas you need to focus on. We'll start with our first one. Understand the benefits of the cloud native applications, microservices, and containerization. So microservices and containerization are designed to improve the speed of software development and also lower cost. Microservices break down monolithic programs into smaller components, which are independently coded and managed. Containerization is a way to store items needed for a program in one contained location. How to gather current and future requirements. The best method is to talk to key stakeholders who are important people and with vested interest in how the cloud will work. Ask the right questions and understand the time horizon for which changes should be implemented. Understand what baselines are used for in cloud assessments. So a baseline is a test that captures performance of a system. For example, one can baseline normal network throughput for CPU utilization. Know how a feasibility study is used in cloud assessments. Feasibility studies are used to determine the practicality of a proposed move to the cloud service. It gets at questions such as, do companies need to require the use of a cloud, and does the company have the ability to migrate to the cloud? Understand what gap analysis does. Gap analysis identifies where the network and organization are now and what needs to be true to get them to where they need to be. Gap analysis focus on business and technical readiness. Know how to use reporting in a cloud assessment. So reporting can help determine if the baseline of a current network performance. If you already have cloud services, the CSP will provide the reports on the resource usage, such as compute, network storage, and resources used. Understand how to use benchmarks for cloud assessments. A benchmark is a standard of performance or a point of reference for a comparison. For example, if you have a baseline read of your CPU utilization, you might not know whether it's good or bad. A benchmark can help you determine that by comparing your data to a known standard. Know why it's important to create documentation and diagrams as part of a cloud assessment. Cloud environments can get really complicated. Document conversations with key stakeholders and potential CSPs so you know what decisions were made and what the next steps are. Document and diagram layouts of where services will reside so new business analyst or analysis or network administrator can look at them, understand how your cloud setup works. That's new business analyst or network administrator can look at them and understand how your cloud setup works. Know who key stakeholders are and POCs or point of contacts. A key stakeholder is someone with a vested interest in the cloud project. Could be an executive such as a CEO or CIO or even a cloud user. POC or point of contact is someone who is responsible for managing communication between companies and the CSP. Know what SSO is? Single sign-on is when users can access multiple systems or resources through a single initial login. Know what MFA is? Multi-factor authentication occurs when a system requires multiple pieces of information to authenticate for a user. For example, in addition to the user's password, which is one factor, the system might require a PIN, one-time password, security code, or answer to a security question. Know what federation is? Federation is much like SSO, but it applies across multiple corporations. It's when multiple companies' security systems trust each other to validate users. When users are validated by one, they can access resources in another federated security domain. Understand the benefits of cloud-native applications, microservices, and containerization. Microservices and containerizations are designed to improve the speed of software development and also lower cost. Microservices break down monolithic programs into smaller components, which are independently coded and managed. Containerization is a way to store all items needed for a program in one contained location. Understand 3 areas of data analytics. The 3 areas you need to know are machine learning, artificial intelligence, and big data. Know what big data is? Big data refers to unstructured data sets as opposed to structured data sets such as relational databases. Know what AI is? Artificial intelligence is when machines are programmed to perform smart human-like activities. Understand what ML and how it is different from AI. So machine learning is when data can be fed into a computer and it will learn from it and adapt. With AI, the computer and the machine can only respond to input it's been programmed to respond with. So with machine learning, the computer or machine can take a novel input and respond to it based on feedback, whether it was right or wrong. It can learn and adapt for future input. Know what digital marketing is and the two common ways it's executed. Digital marketing is the attempted selling of a product or service using digital technologies. Two common methods are email campaigns and social media posts. Understand what anonymous environment is. An anonymous environment is a computerized environment where complex human actions are mimicked without human interventions. Examples include self-driving cars, robotics, manufacturing facilities. Know what IoT is? So IoT is Internet of Things. It's a network of devices that able to communicate with each other via and exchange data. Common applications include home entertainment systems, security systems, heating and cooling systems, home appliances, modern cars, medical devices, and manufacturing, transportation, and infrastructure systems. Know what blockchain is? Blockchain is an open distributed ledger that can securely record transactions between two parties in a verifiable and permanent way. It is technology behind Bitcoin, but can also be used for other types of transactions. Know what subscription services are? So CSPs will often sell their services via subscription services, which means you can pay for the services for a period of time, such as 6 months or a year, often at a discounted price versus the pay-as-you-go model. Understand how the cloud can help collaboration. So there are dozens of cloud-based collaboration software packages which allow users to share, edit files in real time, video conference, chat, and manage tasks. Know what a VDI is? Virtual desktop infrastructure. User desktops reside inside of a virtual machine located on a server. Users can log into the virtual machine desktop from any location with an internet connection or any type of device. Know how clouds implement self-service. The CSP will have an online management interface where the client can acquire and use additional services without intervention from the CSPs. All right, that's everything in our exam essentials. Remember, these slides are out there. I have specific slides for the exam essentials broken down by each chapter. These are like our flashcards, and it's a great way to know where you stand and what you need to study. All right, this would be a good time to review your chapter. You probably you've read it in different areas, but this would be a good time to start from page 77, go all the way to 126. Read through it, make sure that you get all of the concepts. And then after you're done with that, come back here and we'll have a little bit of fun and we'll do the written lab. So here's the written lab, and I like these written labs, as I've mentioned, because sometimes, if you're looking at multiple choice, you tend to guess, but these are really good. Maybe you don't get these the first time, but it's a good thing to come back and jar your memory and make sure that you do understand what the word actually is. And so I feel like it's a little bit better review sometimes than the exam questions. So let's start here. James attempts to sign into the cloud and ask him for a username and password and security code. This is an example of multi-factor authentication. A blank is someone who with a vested interest in a project. This is a key stakeholder. A blank is a comparison of data versus a known standard. A benchmark. The two types of gaps analysis are blank and blank. Business and technical. Self-driving cars are examples of which type of cloud-based service. anonymous environments. Your company pays for cloud services for a year and gets a discount versus paying month to month. This is an example of subscription service. A social media campaign is a type of digital marketing. Unstructured data sets are often referred to as big data. When a computer is able to adapt based on input it's given, this is called machine learning. And then finally, breaking down a large computer program into smaller parts and coding each part separately is an example of microservices. All right, now we're going to complete the chapter with our review questions. So a network administrator wants to implement VDI in your future cloud solution. Which of the following is not an implication of implementing VDI? Higher cost. Company A, a software development team with members located in Geneva and others in Chicago. Which cloud service will best help them manage projects that all of them are working on? Collaboration. Your company is trying to save money by using cloud services. Which of the following is most likely to help reduce the cost of software development? Microservices. You have been asked to perform cloud assessments for your company. Which of the following describes an appropriate order for conducting assessment task? Contact key stakeholders, run a baseline, perform gap analysis, and create documentation. Your company recently signed up for Microsoft Office 365 subscription. The network administrator wants to make it so that the users only have to type in their login information once, and they don't need to log into the local network in Microsoft's cloud separately. What service does she need to implement? Federation. The network administrator, who is part of the cloud assessment team, mentions that the average server CPU utilization is at 40%. What do you use to determine if this is acceptable performance? Benchmark. In preparation for cloud migration, your manager asks you to run a gap analysis. Which of the following is not a likely outcome of a gap analysis? D, determining key stakeholder feedback about the migration plan. A small company needs to set up a security surveillance system to protect its building. Which cloud-based technology will the security system most likely take advantage of? IoT, Internet of Things. The company CIO approaches you and asks you if the company should implement blockchain in the new cloud environment. Which of the following is the best explanation you can give on what blockchain is? It's secure, open, distributed ledger. So remember, blockchain, really all it is a ledger where everybody has access to it and nobody can change it. Your company recently merged with another, and the networks have been combined into the cloud solution. Users need to access multiple resources from different systems within the same security domain. What should your company implement to make access as easy as possible for the users? SSO, single sign-on. Company A wants to assess the possibility of migrating to the cloud. What should they do to determine how much of their current server storage capacity is being used? Run a baseline. A member of your company's purchasing team is negotiating cloud services with a CSP. Over the course of the first year, which of the following would likely represent a cost savings over the other types of payment models? Subscription service. To increase security of your company's cloud resources, the administrator decides to require users to enter password and also randomized security code to log into the cloud. What cloud service does the administrator need to enable? That is MFA. You are performing a cloud assessment for your organization. It's time for you to determine which capabilities can be offloaded to the cloud and the level of support services they need. Which of the following assessments should you perform? Feasibility study. When setting up a new cloud service, you want to ensure that you can get more storage space quickly without needing to call or email the CSP. What cloud service allows you to do this? Self-service. One of the company's developers is creating a software package that can identify human faces and mine footage from security cameras to determine whether someone is suspected of a crime. Which type of technology is best suited for this task? Machine learning. The sales team needs to find a better way, faster, and cheaper ways to engage potential customers. Which cloud service should they implement? Digital marketing. You're performing cloud assessment. What is the final step to take in the cloud assessment process? Create documentation and diagrams. A software developer at your company said he just used the cloud to place his program and all needed library files in one package. Which cloud service is he referring to? Containerization. Your company is debating which cloud-based data analytics solution to implement. Which of the following statements is not true when comparing AI to ML? ML is a form of applied AI.